All right, next up, first up here, I should say, is number 1. So this one, we are going to go ahead and solve this triple system. Our goal for these triple systems is really to turn them into a double system. There's a lot of ways we can do this. I'm going to use elimination, and what I need to do is I need to eliminate the same variable kind of 2 different ways. So looking at all these variables, it doesn't look like any one variable is particularly easier or more difficult than another to eliminate. I'll go ahead and eliminate z's first, and so the way I always do this is I kind of think of this as row 1 and row 2 and row 3. And so if I want to eliminate z's, I'm going to have to do row 1 plus 3 times row z. And because I see that will turn that z there into positive 3z, which will eliminate with the negative 3z. And so I do it like this so I can kind of do it more in my head here. So when I'm doing this, I'm thinking, all right, so we have in this first one, we have x plus 3 times 2x. So that's really going to be 6x. So x plus 6x is going to be 7x. And then for my y's, I have negative 2y plus 3 times y. So that's just going to be plus y. And then for my z's, do cancel. And then for my numbers, I have negative 9 plus 3 times 11. So negative 9 plus 33. And so that's going to be 24. All right, so now I need to use a different 2 rows here and eliminate the same variable, the z's. And so it looks like what I can do now is 2 times row 2 plus row 3, and that will eliminate the z's again, you can see, because it'll turn that z into a positive 2z, which will eliminate with the negative 2z. But I have to do that to the x's as well, so I get 4x plus x is 5x. And then I get 2y plus 3y is 5y. Put that 5y there, okay, and now I have to do it with the numbers. So 2 times 11 is 22, plus 8 is 30. Okay, so now we're down to a system of 2 equations with 2 variables. So now it's kind of more comfortable. So now I'm going to multiply this top one by negative 5. We get negative 35x minus 5y equals negative 120. So we'll add those together. We get negative 30x. The y's cancel, and that equals negative 90. We divide by negative 30, and x equals 3. So now I'm going to take that and I'm going to plug it back into one of my double systems here. So I'll go ahead and do this one right here. So I'm going to say 7 times 3 plus y equals 24. So this will allow me to solve now for a numeric value for y. So I'm going to subtract the 21 over and I get y equals 3. And now I have to take that and plug it into any one of those original 3 equations to find my z value. And I have to plug in x and y there. So I'll go ahead and do the first equation here. It does not matter, like I said. So that's going to be 3 minus 2 times 3 minus 3z equals negative 9. So this is 3 minus 6. That's negative 3 minus 3z equals negative 9. Add the 3 over. Negative 3z equals negative 6. So z must equal then 2. So you always want to list your answer as a coordinate point, as it says there. All right, next up here, it says... it says use matrices to solve the system. Actually, you don't need to use matrices. Just solve the system. So let's go ahead and just solve this same way we did the last time. This one, though, I'm actually going to eliminate the x's. They look like the easiest one to eliminate. It does not really matter, but I see that if I do row 1 plus, and actually I'm going to say minus 2 times row 2, that's going to eliminate the x's here. So row 1 is 2x minus 2x is gone, and then I get 6y minus 6y is also gone, and then I do get, let's see, negative 4z plus 4z is gone. So actually this turns into 0 on the left-hand side. It so happened that all of my variables cancel when I did this. I was just trying to eliminate x, but everything canceled. So I do need to see what that ends up with. And if I do negative 3 minus 2 times 4, that's negative 3 minus 8, that's negative 11. And since this is not true, I can actually stop right now and just say no solution. All right, next up here, number 3, once again, same idea here. And once again, you don't need to use matrices to solve it. You can just solve it the way we have been. So I'm going to first, looks like x's again are very easy to eliminate for me. It may be different for you, but I'm just going to do, let's see, what am I going to do? I'm going to do row 1 minus 4 times row 2. and see what that comes out to. Actually, I don't want to use the equal sign there. I'll do an arrow. So row 1 minus 4 times x is obviously gone. 7y, and then that would actually be plus 8y, so that'd be 15y. And then for my z, I have 14z, and then plus 16z. It's going to be 30z equals 0. All right, and so my next one I will do, I'll just do row 2 minus row 3. Got to be careful with my negatives here. So obviously the x's cancel out there. Negative 2y minus 4y is actually negative 6y. And then, let's see, negative 4z minus 8z is minus 12z. And that also equals 0. So now I have a system of 2 here. So I am going to multiply this by, what am I going to turn these into? I got to turn them into 30 for the y's. So I'm going to multiply this one by 2. I'm going to multiply this one by 5. So this will become 30y plus 60z equals 0. And this one will become negative 30y minus 60z equals 0. And those all cancel out. We get 0 equals 0, which means infinitely many solutions. And so for these ones now, it says that we want to express x, y, and z in terms of parameter c. And so what that means is it wants me to put c as my answer for y. And then I'm going to do my other ones in terms of that. So I'm going to go back to now this my double equation, one of them. And I'm going to isolate y here. So I get negative 6y minus 12. And I'm actually going to insert a c right there as if that was a number for z. And so I'm going to add that over. And our goal here is to isolate y. So we're going to say y equals, if I divide by negative 6, negative 2c. So I'll put negative 2c right there. And so now I need to plug both of those in and find my x value. I'll go ahead and use this middle equation here. It looks like it's the easiest. So I'm going to say x minus 2 times, and now I know this is negative 2c, minus 4, and I know that that's now c instead of z. So x plus 4c minus 4c equals 0. And those cancel out, and I actually get x equals 0 here. So although there are infinitely many solutions for for y and z, there's actually only one possible answer for x. Whatever combination of y and z I have, x must always be 0. It will not work unless x is 0. All right, next up here we got number 4. This one's a little weird here. I'm seeing that they only gave me 2 equations, but 3 variables. So usually this doesn't work, but I'm just going to go ahead and try it here. I'll try some elimination. So I'll do, actually I don't want to show it like that. I'll do, I'll do row 1 minus 3 times row 2. And I'll see if that, sometimes this will eliminate 2 variables, and then I can just kind of be done, or I can get down to that 1 variable and figure it out. So in this case, the x's do cancel. This turns into 1y, and then this would turn into 8z, and then that's going to equal, let's see, 7 plus 6 would be 13. And there's really nothing else I can do. And so what I'm going to say here then is that because I have 1 equation with 2 variables, or if you want to think of it, 2 equations with 3 variables, there's just, I know, going to be an infinitely many solutions here. Just because there's not enough information given in the problem. So I am gonna again, just like last problem, write x, y, and z in terms of the parameter c. So that just means they want me to define the z as a c. And so now I'm going to isolate y on this equation in terms of c. So y plus 8c equals 13. So y equals 13 minus 8c. Okay, so then that's going to go right there, 13 minus 8c. And now I'm going to need to plug both of those into either one of the original equations to find x. So for that, I'll use that second equation there. So I get x plus 4, and then instead of y, I'm going to put 13 minus 8c, and then minus c equals negative 2. And so I get x plus 52 minus 32c minus c equals negative 2. So x plus 52 minus 33c equals negative 2. And I'll go ahead and subtract 52 over and add 33c in the same step. And so that gives me x equals 33c minus 54 from combining those like terms. So that's what's going to go in for my x. All right, so next up, number 5 here. So it says here that we're going to sell this 1 pound bag of coffee, and it's going to be a mix of these all three, which I'm going to call X, Y, and Z. And so that means that if we add up kind of all the weights of all the coffees here, it's going to equal 1. And then we're going to do the cost here. So it's going to be 14 for the first one, and then 9 for the second one, and then 12 for the last one. And then that's going to equal, our total cost here is going to be $12.60 per pound. Now, in this case, so what we're going to have to do here is we're going to have to multiply this by x plus y plus z to represent that it's 12.6 for every pound that we have. Now, in this case, on our other equation, we already kind of had that x plus y plus z equals 1. So in this case, that is actually a 1. But there will be other questions where you do mixtures like this, and you have to multiply that by the sum of the variables. All right, so then our last equation here is going to be a comparison. It says Colombian, which is x, is 3 times the amount of Costa Rican. So that's going to be x equals 3y here, because the Colombian is more. We have to multiply the Costa Rican by 3 to get to the Colombian. So I'm going to start with a substitution here to just get it down to 2 variables. And so I can take out these x's and put in 3y every time I see that. So this first one will be 3y plus y. So I'm going to write that as 4y plus z equals 1. Now this other one will be 14 times 3y plus 9y. So I'm going to figure that out off here on the side. 1242 plus 9y. So that's going to be, for me, it's going to be 51y plus 12y equals 12.6. And I'm going to go ahead and multiply that by 1, which is done. All right, so now I'm going to solve this one by multiplying this one by negative 12. So that's going to give me negative 48y minus 12z equals negative 12, which would mean that 3y equals 0.6. And if we divide by 0.6, we get y equals 0.2, which is really 1/5. So that's my answer for Costa Rican, is 1/5 of a pound. It does make sense that that's less than 1 because why? Because we're only making 1 pound of coffee here, so each one of these should be less than 1. Okay, so the next up, I can find x really quickly here by using this equation. So x equals 3 times 1/5, which is obviously 3/5. And then lastly, it looks like I have 4/5 together, so this last one will also be 1/5 for me. All right, next up here, it is saying, what is it saying here? Oh, so it's giving me 3 points here, and it's giving me a function. So I know that these are all x's, and then these are f of x's, so I can actually plug all of these in for x and y, and leave a, b, and c as variables. So my first one will say negative 17 equals a, I don't know. I know x is negative 3 to the 3rd power, plus b times negative 3, plus c, I don't know. Now I would actually simplify that to say negative 17 equals negative 27a to the, just negative 27a minus 3b plus c. All right, next up then, I can do the same thing again with the second point. So it'll be 25 equals a times negative 1 to the 3rd plus b times negative 1 plus c, and that'll translate into 25 equals negative 1a to the, no, not a to the 3rd, just a, minus b, and then plus c. All right, and then the third one, would be 28 equals a times 2 to the 3rd plus b times 2 plus c. So then I get 28 equals 8a plus 2b plus c. All right, so now we have our triple system here. Kind kind of right over here now that we can use. And so I'm going to use that going forward here. It looks like eliminating C's would be very easy here. So I'm going to start off by doing R1 minus R2. So R1 minus R2 would give me, let's see, 17 minus 25. I'm actually going to add those up. So it'll be negative 42 equals negative 26A, and then minus 2B, and the C's cancel. Yep, that's all good. All right, and then I'll do R2 minus R3. So that'll be negative 3, and then this one will be negative 9, and then negative 3B. Oh, sorry, this is negative 9A there, sorry. And then minus 3B. Okay, great. So now I am going to go ahead and we'll do some elimination here. Looks like I can eliminate the B's. So I'm going to multiply this one by negative 3, and I'll multiply this one by positive 2 and just rewrite both. 42 times 3, it's going to be 126 equals 78A plus 6B. And then this one will be negative 6 equals negative 18A minus 6B. All right, so this will be 120 equals 60A, which would mean if I divide by 60, that A equals 2. I can then plug that back into any equation. I'll go ahead and use this second one right here. So I get negative 3 equals negative 9 times 2 minus 3B. So I'll add this 18 over. And I get 15 equals negative 3B, so B equals negative 5. And then I can plug that back into any one of the original 3 equations way back here. And it looks like that middle one is pretty easy, so I'll go ahead and do that to finish. So 25 equals A is 2, so negative 2, and then plus 5 plus C. So 25 equals 3 plus C, so if C equals 22. All right, next up here, number 7. So an investor invests $44,000. That's a total into X plus Y plus Z is 44,000. And so I'm going to call this X and Y and Z. All right, and then it says their percentages here, and then the total percentage. So on this one, what we're going to do is we're going to go 0.04x plus 0.05y plus 0.06z. And then this 5.25%, that's saying that's the percentage of the original amount. So I'm going to say that this is going to equal 44,000, what I invested, and then we want to get a 5.25%, so that's 0.0525 return. So that's my second for the setup for the second equation. And then the last equation here, I do have a comparison, same equal amounts in the short and intermediate. So that's just going to mean that X equals Y. Okay, so now I'll go ahead and solve this. I would use substitution first to just turn all of these X's into Y's, since I know that they're the same. Or you can turn the Y's into X's, doesn't really matter. So then I get 2Y plus Z equals 44,000. And then 0.09y plus 0.06z equals, and then I would go ahead and multiply this together. And that gives me 2310. All right, and I would then multiply this by negative 0.06 to eliminate those z's very quickly. So this will be negative 0.12y minus 0.06z equals 44,000 times 0.06, and that's negative 2640. So now we'll add those up. Negative 0.03y equals negative 330. So if I divide that by negative 0.03, then that means that y is a positive 11,000. And then, so I know if that y is a positive 11,000, x is the same as y, so that will also be 11,000. And then I know if they all add up to 44,000, this last one must be 22,000. All right, next up here it says first find the common difference. So that's just kind of tracking the pattern here. So what's going on, I think it's a minus 18. If you wanted to, also you could do a2 minus a1, but it's just negative 18. So you could, like I said, do a2 minus a1. So then it's just saying what's the next number in the pattern. So I'm just going to subtract 18 one more time. You get negative 50. And then for the a sub n, that is your kind of mx plus b formula. So I think of it as negative 18 is my slope. So instead of negative 18x, it's negative 18n. And then I do need kind of a sub 0 here. Since this is a sub 1, I need to think what would the number in front of that be. And so if I added 18 to that, that would be 40. And so I'm going to say that's plus 40. You can always check this, though. Plug in a 1 and see if you get the first term, and I do. If I plug in a 2, I get 4, so that works as well. So it should accurately predict every number on the list. And then for a sub 100, you're just going to plug in a 100 for n. All right, next up here, we have a recursively defined sequence. So this is saying the next term in the sequence is going to be found by taking the previous term in the sequence and doing this. So I know that a sub 1 is 3 since that's a given. So then for a sub 2, it's going to be 2 times the previous term a sub 1 plus 2 for me. And so I know the previous term is a 3. So that's going to turn out into 10. And so then for a sub 3, it's 2 times the previous term, which is now a sub 2 plus 2. So that's 2 times 10 plus 2. So you just keep plugging in those answers and moving along my list. So this one is going to be 24. And I'll let you guys figure out the rest. All right, next up here, it says how many ways can we rearrange 3 blue marbles and 4 red marbles arranged in a row. So arrange does mean that order matters, and so it is a permutation. But we do have repetition here, and so whenever there's repetition, it's what we call a distinguishable permutation. And so we have to put 7 factorial on top for the 7 total that we have, but then 3 factorial and 4 factorial on bottom for the repeaters. So anytime you have order matters, but you have repeaters, go ahead and throw those on bottom with a factorial. All right, here again, it says how many ways can these 3 positions be chosen from a class of 16 students. So a couple ways you can look at this. I see it as a permutation because the order does matter because it's different jobs. So you can do 15p3. Or if you want to do it logically, you can think we have 16 people that could fill the first spot of president. Vice president, we have 15. And then secretary, we have 14. And those numbers are decreasing by 1 every time because each time we kind of pick up a candidate or pick up a person, select a person, then they can't do a different job. All right, next one here says man has 10 pairs of pants. How many ways can he choose 3 of these to take on a business trip? So it sounds like the order doesn't matter in which he chooses them, so that's going to be a combination. And so I would say this is 10C3. All right, next up here it says a jar contains 5 red balls, 1 through 5, 8 green balls numbered 1 through 8. Okay, so let me visualize this. So I'm going to go in my red pen. I'll go 1, 2, 3, 4, 5, and then my green pen, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so first one here says ball is red given that it is numbered 4. So when it says given that it's numbered 4, I'm going to isolate all my 4s there. So I have 2 of them. So that's my denominator. And how many of those are red? Well, obviously 1. Next one says ball is green given that it is number 8. So I'm going to isolate my red ones. And so I see that that is 1 out of 1 because the only green ball the only number 8 ball I have is green. So out of all the number 8 balls, the probability that we get a green one is 1 out of 1. And then next one is probability that the ball is red given that it is an even number. So I need to look at all my even numbers here. So I got evens, 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 evens. So my denominator here will be 6, the total number of evens. And then how many of those are red? Well, there's only 2, so that would be 1 out of 3. And then lastly, let me get another color for this. I'll go pink. Ball is even given that it is red. So this one I'm only looking at the red ones, so there's 5, because it says given that it's red. And then what's the probability that it's even? Well, there's only 2 out of those that are even. All right, next up here, it says we got some color balls in the, I don't know, in a jar. We're going to pull 2 out without replacing them. So the first one is black. That probability is going to be out of 10 for me, the total. We have 7 black. And then let's say we got a black one on the first time. That means there's only 9 total. But if I want that second one to be white, there's still 3 white ones. So we're going to multiply those together since we need both of those to happen. All right, and then if they're both black here, it's going to be 7 out of 10 again for the first one, but the second one will be 6 out of 9 because we're assuming I did get that black ball on the first try.